Today we are going to discuss about the introduction to SAP HANA. So what is SAP HANA? What is it for? Everyone concerned to know what is SAP HANA. SAP HANA is nothing but appliance. So it is something like SAP HANA. So why HANA is came to it? So in daily life there is millions and millions of data is coming up and hitting into the database. So that's why. So there is no to make the transactions in the database, or we wanted to generate the reports, we wanted to analyze the data in the database. It is not possible if it is a large amount of data. So that's why HANA came into a picture which can analyze the data, large data in a single instance, which is nothing but a HANA. So HANA is a kind of in-memory computing unit. So I just want to tell you the difference between the OLAP system and the OLTP system. So this is an OLTP system, which system is SQL. So if the transaction is occurred in the OLTP system, if you want to generate a report here on OLTP system, it is when the report fits, if any transaction fits the data, it is very sensitive. So that's why we are building a OLAP system. So we are making the reports on top of the OLAP system. So it is nothing but data warehouse concepts is concerned. So let's say if you want to, if any transaction comes in, it's data for the reporting purposes. It is since OLTP system is a very sensitive system. So if anything goes wrong, the entire system will go off. So that's why we are building up a OLAP system so that we can generate on reports on top of the OLAP systems. So that's why it is more reliable for the the reports. Online transaction processing, online analytical processing. So this is the difference between the OLAP system and so why the OLAP system is, so why don't we build a system? Suppose the OLTP system is in Houston. Suppose there is a large company, there are several OLTP systems. So we cannot build reports, we can build reports particular to the Houston or particular to any city. Suppose I have two Houston and Miami. So if you want to build reports on top of the OLAP system, we can build the reports and it's very sensitive and you cannot if any transaction goes off and it is so if you want to build a report on top of the OLAP system, we can combine this with several OLTP systems to the OLAP system. We can generate the report on top of the OLAP system. So this is the difference between the OLTP system and the OLAP system. So HANA, so where So why we are telling this concept? So why we know about the OLTP system and all that system? So HANA, so in business objects, we're building in universe. So here we are connecting to the SQL server. In business objects, we are connecting to the SQL server or Oracle or the OLTP systems. So we are creating the universe that is a OLAP system. We are creating the reports on top of the universe that is an OLTP system, that is a warehouse. And we will connect the tables and we will develop a data warehouse and we will develop reports on top of the business universe. So that is the difference between. So why HANA is a OLTP system or OLAP system? HANA is a OLTP system. So we can generate the reports on top of OLTP systems. It is designed in such a way that we can generate the reports on top of the HANA system. Why? Because we can connect multiple HANA systems. We can connect multiple HANA systems and generate the report on top of it. Okay. I'm going to discuss a little bit about the. So yeah. So I'm going to discuss the main things in HANA system. So there is GBs and TBs of data is coming up daily where we have to store it. Usually for any OLTP system it can store up to the 3 months of data. Even if you see the bank systems, so there is we can get the statement only for the previous 3 months, not the entire year or not the previous year. If there is a special request that you have to make the transaction and get the data of the years. So why? Because the transaction is happening daily, there is a lot of data coming up. So whatever the data that we are coming, so that has to be in the OLTP system and on the primary storage, and the rest of the data is sent to the secondary storage, which is not OLTP system. So there will be limitations for that one. So I'm going to discuss about the how the performance is on HANA system and how is the performance of the normal SQL, Oracle, or Teradata Hadoop applications. Interesting. So, yeah. So I want to discuss about the in-memory computing engine. What is in-memory computing engine? Suppose we in a daily life we are using a laptop. So it has 500 GB of hard disk, and 6 GB of RAM. So when a transaction or any process happens, the data has come from hard disk for the processing RAM, and after doing the process it has to move from RAM to hard disk to store the data. So in the case of SAP HANA, there will be no hard disk, there will be, suppose if you think, so for 500 GB, if the 6 GB of RAM is enough, suppose if you make this RAM as 500 GB, and how fast should be the performance? It will be in snapshots we can do the performance. So HANA is coming to a technology, it's in-memory computing engine. There is no hard disk, there is only one thing, that is 100 GB RAM. Here only, if you see the architecture, then you will see how the data is stored and how the transaction will happen. We also have an architecture that will see in the later architecture design. I will tell you how the data is stored. There will be a persistent layer. If any crash is happening in a normal system, there will be no data coming from the RAM to the hard disk, because it's a volatile memory. If the cache is happening, there is nothing is sitting inside the RAM. If the same crash is happened inside, the process is going inside this, even though the cache is happening, the data has to be on the RAM itself. It is not going anywhere for the hard disk or something else. So even though the crash is happened, the process is running on, it is storing here. Even the crash is happened or anything like power fail or something happened, the data has to sit here on it. If it is going away, then it not goes. It's an in-memory computing unit. It's a RAM. Okay, so I'm gonna tell you the differences between it is in SAP HANA. I'm gonna tell you the four main things. One is row store and column store, and the other thing is row store and column store. The second thing is compression techniques, and the third thing is and processing. So this comes under, I'll explain all these things at a single instance. I'm going to take a little sample example, and I'm going to tell you how the row store and the column store is really happens. Okay. Let us take a table in a SQL server and how it is stored in a row store, and I will tell you the difference between a row store and a column store differences. So I have a table here which has name and Sarah. Okay, and I have a data Raja getting something like $5,000, and next one getting $5,000. Victor is getting salary of $6,000. We have a fields here, and I'm gonna tell you how the roster table how it is, and the column store table how it is. In a roster table, the data is in the form of rows, so we're gonna store the values like Raja 5,000. It has row 1. So 5,000 as row 2. Victor 6,000 as row 2. The data is stored in the form of rows. So the processing is also to happen on row wise. Process 1, process 2, process 3. It's a row store process. So the row store process is P1, P2, P3. Each process has to go to the individual column. It has to go to the name column, it has to go to the salary column. Whereas in the column store, Raja, Victor, is considered as one column, and 5,000, 5,000, 6,000. So why it is putting 1 here instead of 5,000? Why? Because of the compression techniques, if any value is repeating again and again, then the analyzes separate compression techniques so that it won't repeat the values. So if we have 5,000, it is value of 5,000 is repeating 100 times, then the value of 5,000 is not repeating like 5,000 times or 100 times, 200 times, whichever it may be. So it will have only a value that will refer to the 5,000. So if I have a 5,000 and the value 1, it will refer to the 5,000. If the 6,000 is repeating 100 times, then we know to how to store the 6,000 100 times. It has a value that refers to 6,000, and there is a compression techniques. That is if you want, if the process goes on the column store, if you want to aggregate these processes, then we want to make a sum of all the just process these elements, then we'll get the result. Either it is a sum or print or max or count. This is the difference between the row store and the column store. It is a compression techniques. In the column store, the compression technique will happen if it, so the 5,000 is compressed to 1. Even if you are again apply and one more compression to this one, and it will always show one more value, another compression technique. Okay. That is the difference between the row store and the column store. The process will run on row wise, and here the process will go on column wise. If you want to aggregate any column, the process will directly hit the column. If you want to aggregate these fields, it will show the sum. If you want to aggregate it, it has to go individual field and from this data. It has to go row wise and column wise. Okay. And what is the compression technique? I'll tell you that how the compression is happening. Okay. In a column store, we already discussed that the compression, if the value is repeating, the compression is taking place. So how it is processed? Compression is happening here. Even the compression is happening, and it's parallel processing. I had always seen if the parallel processing is happening here, each process has to go to the individual columns. It's the name column or the salary column or any individual columns. If the parallel processing is happening here, each process has to go to the individual columns. It has to see only the names. It only checks only the salaries. Let me illustrate with a simple example. Suppose those are called a dedicated process. Suppose we have a set of 10 red pens and 8 black pens, 7 blue pens. Okay, how the row store will search and how the column store will search, how the process will happen. Okay, if we have a process here, process 1, process 2, process 3, each process will search if the process will search for 3 red, 2 black, 2 blue. Likewise, each process will search for the different it has to complete. If you aggregate these things, the process has to run. There will be a super process which will aggregate all these process based upon this is the requirements. If you want to aggregate this in how many black pens and how many blue pens, there is a super process that will hold all these process based upon the aggregation that we apply. It will show the result in the super process. Whereas in the HANA column store, if there is a set of values, there will be a dedicated process for each column. So in the above example, there are red, black, blue pens also. So there is a dedicated process for red pens. There will be a dedicated process for blue pens. And there will be a dedicated process for black. So if you want to aggregate the data, it has its own aggregation. The process has its own aggregation. Then we don't need an extra process to aggregate these all values and grouping everything. So this is called as aggregated parallel processing. Parallel processing happening in row store and parallel processing is happening in column store. Dedicated parallel processing for each column. The high performance such as HANA just will revise everything. HANA is a high performance analytical appliances powered by SAP system application products for data processing. So it is an OLTP system. There will be no OLAP system. So we are building the reports on top of the OLTP system. So HANA has its own variety of OLTP systems, so we can connect different OLTP systems and generate the report in a very computing engine. So the RAM itself inside, there will be no hardware. The RAM itself also had this. So the process will be much more higher and efficient than the other technologies and events concepts. So row store and a column store. So here in a SQL Server, Oracle, REST data, Redis, anything, the data is stored in the form of rows. So if you want to fetch the data, the parallel processing happen, it has to go for different rows. In a column store, the values will be stored in such a way in the form of columns. If any aggregation is anything happening here, the process has to dedicate it to this column, and this process has to dedicate it to this column. The compression techniques. If it is in the column store, if there any value is repeating, like here it's 5000. If it is repeating more than 1, it has to compress it with another value. And other compression techniques are there, even we can compress the one into other thing. Like this, not only for the numeric values, it also apply for the characteristics, any values. That is the compression techniques and the row store and column store. The parallel processing are the same thing. Here the parallel processing is effects on the row wise. Here the parallel processing is effects on column wise. These are called as dedicated parallel processing. Each process will be dedicated to each column. So it will be much efficient than report store. And I'm going to tell you, illustrate an overview of I'm going to tell you what are the topics that we're going to cover in this session. Uh, in this session, we're going to see the HANA architecture. What are the different engines are present in HANA architecture? Engines present in architecture. There will be different engines, OLAP engine, join engine, and different engines that come. We will see all together in a HANA architecture. What are the different engines and how they will perform. And there will be, as usual, there will be a database, in-memory database. So HANA is much more faster than the other process. So if the if there is a million, there will be a million records. If you want to process a million records, it is the time taken for a regular RDBMS to process the data, like 10 hours. Whereas in HANA, if the same data is present in HANA, what is the time taken to process the data is less than 10 seconds. So if the user wanted to run the report on top of the RDBMS and the HANA database, which will be the more efficient one? The HANA database is the more efficient one. So that's why the people, industries are moving towards the HANA database. Regular database, and it is database. So this is a difference that you need the 10 hours data, process data, it is coming up in 10 seconds. So probably the client needs the much more function. Okay, I'm going to tell you the overall thing, how it is, how the HANA is. Okay, there is a HANA box. It is installed on SUSE Linux box. So it has an engine, several engines, and several compressions, several parallel processing, and everything. Everything comes under the HANA. There will be database, and on top of it there are engines. So if the HANA okay, so if it is a fast process, what about the other DBMS and what about the other databases? So if I'm a client, if I want to move my SQL Server or Oracle database to HANA database, how I can transfer the data, or how can I perform? How can I move the data, or how can I replicate the data to the HANA database? So we can build the reports on top of the HANA database. See, the HANA is on the middle side. There will be several reporting tools that we can develop on top of HANA database. We can develop early reports and desktop reports, and we can develop MDX reports, and we can develop SAS reporting tools, SAS. SQL, Tableau, SSIS, SSRS, or any reporting tool. There are several reporting tools. So near the end thing is we can develop the reporting tool, or we can connect to Java applications. This is where the user can input the data UI files, UI file, where the user can insert the data from the user interface file and retrieve the data in form of reports, or you can develop its own Java database reports. It uses the JDBC connection. Whatever the connection that uses the Java application, that is called as JDBC connection we will use. By using the UI files, we can insert the data and we can view the data. By using the reports, we can simply view the data. So, okay, we can insert the data and we can view the data from here. What about the existing data that is present in different databases? So here we have SQL Server, Oracle, Hadoop, Teradata, Excel, text, CSV, MySQL, Sybase, DB2. There will be several. You can extract the data from ECC tables. You can extract the data from BW system. There will be several data sources. Extract the data from web data, like HTTP data. So what about the existing data? How we want to load this data to a HANA database and develop the report? So that's why we are using several replication and the process of getting the existing data to the HANA database and build the report is called as data provisioning. So the data provisioning is a huge concept. Here the data provisioning is mainly divided into three parts. One is using business objects data services, and another one is using SLT replication, and another one is by using these services. Business objects data services is a trigger based replication service. Sorry, batch SLT replication and DXC. Okay. We have the data here and we have to get the data into the HANA database, so that's why we are using either we will use a pods, or either we can use SLT, or either we can use DXC. So if it is a BW model, we can use either DXC or pods. For SLT replication, either we can use is a system or non-SAP system. So here also it is connected to UI files. At a different Java, and not only the UI files, but maybe web services. line. So if any changes happening to this data, if you are building a report, it has to replicate in the HANA database. So using the SLT replication server, if any changes happening to here, it has to immediately reflect in HANA database so that it will be more feasible. If there is changes happening in this uh, databases, but there is no changes in the HANA database, there is no user building reports on top of the HANA database. So that's why we are using the real-time replication techniques. So if there is any changes happening here, we will replicate this data, or we will trigger this data, or we can directly extract this data to the HANA database and we can build a report on top of it. This is called data provisioning. So in the regular sessions, we will see how the data provisioning happen and how the things happen, real-time scenarios, and we will see everything. Apart from that, I'm going to show you the course content. So how our classes will be. Here is so here is it is a sure. So here is a course. It's a 20-hour course. So today we are going to discuss the in-memory computing engine and row store, column store, and parallel processing. So tomorrow we're going to discuss the different editions in SAP HANA. What is a platform edition? What is enterprise edition? What is an extended enterprise edition? Platform edition, I suggest simply HANA Studio. Enterprise edition is along with the boards or SLT or DXE. It comes from the enterprise edition. Extended edition is comes from the cloud platform or any other services, any other services, mobile development or anything top of HANA that is extended enterprise edition. So we're gonna the next classes we'll discuss the HANA architecture. What are the different engines in HANA architecture like access engine, OLAP engine, join engine. There are several engines in HANA architecture. We will discuss in SQL script engine, calculation engine. We will discuss everything in the HANA architecture, different engines and different managers, how the database is stored and how the logs are stored, what is the persistence layer. Everything will come from the HANA architecture. And the 2-hour course of if you are from the non-SAP, non-SQL side or BW sources or any Java side, so we'll cover the basic SQL in 2 hours, like select from where, order by, group by, having, count, top, insert, update. This is a very basic SQL. We'll cover this basic SQL within 2 hours. So how the tables are joined. There are different joins in the database, that is inner join, left outer join, right outer join, full join. These are in regular DBMS, and there is a 2 different joins, like the referential join and text join. That is especially in the HANA database that we will see in the next session. The modeling part comes under attribute views, analytical views, and calculation views. If the attributes views are only master data, joining the tables is nothing but attribute views. Analytical views are the fact table on top of it. Attribute views is called as analytical views. If more than one analytical view you wanted to join the analytical view, it is called as a calculation view. Then we will see how the real-time scenarios will go on and what are the errors we will get and what are the things we will do. We'll see in the later session. the procedures, the set of activities, uh, set of actions it has to follow a procedure. Will create procedures. If the user want to decide any other column based upon the saves or anything, we'll create the decision table for the user so that the user can easily change their decisions based upon the requirement. And under the HANA database, there will be a schemas. There will be several types of schemas. There, user-defined schema, system-defined, and schema. There will be tables, views, procedures, creating triggers, creating sequence, creating indexes, creating segments. We'll cover that thing. Regarding the data provision is a main important topic. How the existing data has to be come on the HANA database. We'll cover the real-time scenarios like how create a data store, batch jobs, real-time jobs, how to schedule jobs, moving the data from BW to HANA, ECC to HANA, SQL Server to HANA, Oracle to HANA, Sybase to HANA, MySQL to HANA, Derived to HANA, Hadoop to HANA, that file to HANA, Excel to HANA, using the bots. By using the SLT, trigger-based application server, we will extract the data from SAP sources and non-SAP sources to HANA. So direct extractor connect, extracting the BW models directly to the HANA database. You see, backup and recovery, one class is enough. And how to backup the data and how to recover the backup data. So under security, there will be like several rows. So we will create a calculation view. It has like country-wise sales. So I have there is a calculation view built up, and I don't want it to see the users or I will create a analytical view on top of the calculation view, so that even the calculation build up for several countries, the particular country which is accessing the database, accessing the calculation view can see only the sales of their country. If I build a calculation view for all the countries, if I am accessing that calculation view for, if I am in India, if I am in, I'm accessing that calculation view, so I only get the data sales of India. If he is in Germany, we get the data only from Germany. And administration part, how to transport packages and how to import the data and how the replication is done. Is there any happening while doing replication, something stuff we will see in the administration. And quick launch icons, there will be like several icons will be there in the quick launch, and we will see how each icon will perform actions. This is HANA course content. Yeah, and thanks for joining the session. See you. Any questions and anything? Let me know.